Alright, hello. How are we all doing? It's Wednesday, it's getting on towards midday. Hopefully everyone is doing alright. Hopefully everyone is well. Hello there. Hopefully we're up for thinking about a little bit of maths. Okay. So one thing to bear in mind before we get started with today's stuff is that if you were watching the video from last time and you were thinking, oof, I'm not entirely sure about this, I might need to go and practice some of this stuff a little bit first. You might want to do that before kicking ahead with this video, okay? The video today, we're going to be looking at, some situations where we might not have roots, where we're dealing with some more complex quadratics, and we're going to be thinking about some extra bits of information as well that we could be asked to find. It's not within the realms of impossibility, but they will kind of add features to our graphs. Okay, so I would, if you knew what you were doing last time, you were pretty confident with it, you were getting things right, this is absolutely the video for you. And if you were watching it and thinking, I'm not 100% sure with this, or even 80% sure, maybe go back and have another look at that one. Okay, so with that out of the way, what we're going to be looking at are some scenarios where we've got some quadratics which are not as friendly to look at or to work with. So calculators will have to be at the ready. Okay, I've got mine here ready to go. We will also need to think about the process that we do really carefully, and then we will also kind of be using some of the skills that we used last time as well. Okay, and we're going to do it mostly in the sense of I will give you a chance to have a go at one yourself, and then we'll kind of go on from there. Okay. So our first quadratic that we're going to have a look at today is going to be the quadratic y is equal to 2x squared plus 4x plus 1. Okay. Now, that quadratic is already a little bit more complicated because it's got that 2 there. But what we're going to do to start off with is we're going to look to take a factor of 2 out. And this is going to be the awkward thing, the 1. Now, we can still take a factor of 2 out. It's just that that 1 there will have to be divided by 2 in order to take a factor out. So we're actually going to end up with a fraction or a decimal at the end here. Okay? Nothing wrong about that. That's something that we're going to have to be careful about. So for quadratics with like a number times x squared, we need to factor that number out. And what we mean by that is we want to write it as whatever that number is, and then a big bracket. Okay, so then we get a quadratic inside of the bracket, which is one of the a type of quadratic that we know how to deal with quite well. Okay, so if I take a factor of 2 out of everything, 2x squared would just become x squared. Take a factor of 2 out of 4x would mean that we get 2x. And take a factor of 2 out of 1, that would leave us with a half, or 0.5. Okay, now if I were to expand this bracket that I've got here now, I should end up back with the quadratic that I started with. So they're still talking about the same thing. It's just that now this we can complete the square of a lot easier. So we want to complete our square. Now, the 2 on the outside has got to stay there. That's not disappearing anywhere. It's staying there because it's part of our quadratic. But what I'm going to have to do inside of that big bracket is now set up our completed square. And hopefully from last video, you can remember how to do this. We half the number in front of the x's, not the x squareds, but the x's. So half of 2 is 1. And then we look at the number at the end. Well, 1 squared would be 1. I don't want 1. I want a half. So I'd have to take off a half. Okay? And what I'll do sometimes is that I'll write, like, if I've got a big bracket that goes around lots of things, I'll do like a big square bracket just so I know where all my brackets start and finish, because otherwise we could get quite a bit muddled up with all sorts of things going on. Okay. Now, at this point, because we have we've completed our square, we now need to kind of re-expand the big bracket so that we can figure out where our vertex is and where our roots could be. Okay. So let's re-expand. So we're going to get y is equal to 2x plus 1 all squared. 2 times a half is 1. Now, if you remember from last time, I'm just going to shift my notes across to something that we used last time so that we can see. So, last time, we used the completed square form to find out where our vertex is. So the number at the end was the y-coordinate for our vertex, the turning point. And whatever made the bracket equal 0 was our x-coordinate for our vertex. So for our vertex, this is our y part. And the bracket we solve for x. Okay. So when x plus 1 equals 0, x equals -1. And the y part is just -1. So our coordinate, -1, -1, that is our vertex, or our turning point. So in our graphing software, we're going to put a coordinate at -1, -1, just there. Now we need to check if we've got any roots. Okay, so for the roots, we solve that equation. Or we could solve 2x squared plus 4x plus 1 using the quadratic formula. Okay, there are two choices that we could do. If you know how to use the quadratic formula and you are happy doing that and you can do it well, then that might be a great alternative. But either way, we're going to look to try and solve this equation to find our roots. Okay, so I'm going to go for that option. So if I'm solving this, I'm trying to get x by itself. So let's start off by adding 1 to both sides. Okay. Now, I will need to divide by the 2 outside of the bracket before I can square root both sides. Okay, so I'm going to have to divide by 2 to get x plus 1 squared is equal to 1/2. Now I can square root. And remember that when you take a square root, you get a positive and negative answer. That's why we get the 2 answers. And then I'm going to take away 1. So I'm going to get -1 plus or minus the square root of 1/2. Definitely calculator time. Okay, so let's shift that up a bit so we can see. So we've got -1 plus the square root of 1/2. Decimal time. -0.29. Okay. What about x with our little negative? So let's change that positive to, oh sorry, a little plus to a minus. Again, we get -1.71. Ew. Okay. So I've just typed those things into my calculator, okay, and got those answers. They're not particularly nice, okay? And trying to plot those accurately on our graph, you know, if we were doing it by hand, would be a little bit awkward. We would just have to do it the best that we can, okay? Fortunately, for some graphing software, I can do it pretty much exactly, okay? So I'm going to have 1 point there, and I'm going to have another point there. That's what our roots are going to be. Let's check it out. Yes, success. Okay. So for a slightly trickier quadratic, okay, one with the numbers in front of the x squareds and things like that. The thing that really changes is the kind of how we start it off and then kind of getting to this stage here. Once we get to this stage here, the actual what we do afterwards is mostly the same, okay? It's just the little setup at the start that is that little bit more awkward, okay? Now, something to watch out for, okay? Something to watch out for. If you get to this point here, and you get a negative number here, then you will have no roots. So if this is negative, you have no roots. Okay, which means that the graph will not pass through the x-axis. Okay, so it could be that our quadratic curve is like up here somewhere, okay, and doesn't go through the x-axis. Okay, that is a possibility. Okay. So, what I would like you to do now, this is the part where you have a go for a little bit, okay? I would like you to have a go at the quadratic 2x squared, take away 4x, plus 4. Okay? I would like you to have a go at that one. And I'll give you 4 minutes to see where you can get up to with that. Okay, and then after 4 minutes, I will start ticking through a solution so that we can see how we're doing with that. Okay? I'll restart the timer. Whoop, 4 minutes. And away we go. And as always, if you have questions, do make sure that you ask them. Oh, yeah, it is still y is equal to, okay? So the bit that we really need to kind of focus on is this bit here, okay? Our quadratic could say y equals 2x squared minus 4x plus 4, or it could say 2x squared minus 4x plus 4 is equal to 0. But that bit, so long as it equals 0 or y, is fine. It's fine. No problem. Okay, let's start putting some bits together. Okay, I've only got a limited amount of room, so we'll see how we do for space. If needs be, we will grab some more. So, complete square and factorize out. Okay, so we're going to factorize out a 2. Okay, so we're going to have 2x squared minus 2x plus 2 is equal to 0. We're then going to complete the square. So we got 2 big bracket x take away 1 squared. Negative 1 squared is 1. I don't want 1, I want 2, so I need to add an extra 1. Is equal to 0. And then we re-expand to get rid of the big bracket. So we get 2 lots of x take away 1 squared plus 2 is equal to 0. So for our vertex, we look at when the bracket is equal to 0 and the number at the end. So our vertex is going to be at when x is equal to 1, because 1 take away 1 is 0, and when y is equal to 2, so at 1, 2. Let's get a point in at 1, 2. So there. Next thing, roots. So if you shall we solve the use the quadratic formula? No, I'm not going to. Okay, so roots. We want to solve the equation like that. So we take the 2 from both sides. So 2x minus 1 squared is equal to negative 2. Okay. We now have that negative number there. Okay, and as we said before, if this number is a negative, we will have no roots. Okay, and that kind of makes sense, actually, now that we look at it, because our turning point is all the way up here. Okay, how can our turning point be up here, us have a positive quadratic, so we know it's got to have a U shape to it? How can our turning point be up there, have a U shape, and it pass through the x-axis? It can't happen. Okay? So all I can do at the moment is to just go, well, our quadratic goes through this point and has roughly a U shape. Yeah, it does. That's pretty much it. Okay? Now, at an AS level, if you're thinking about stepping your game up, as well as having vertex and a root, we might want to think about our y-intercept. Okay? And this is just when x is equal to 0. Okay? So when x is equal to 0, we have 2 lots of 0 squared minus 4 lots of 0 plus 4. 0, take away 0, plus 4 is 4. Okay, so we have our y-intercept just there. Okay. I suppose that we could be asked to find that, but normally we're all concerned with roots, vertices, things like that. Okay. How are we doing? We're on... Okay. So... Okay. I'm going to put something up for us to have a think about, to have a go at. But before we get started, I'm going to give you 30 seconds to think what your first step is going to be. okay? Because the first step is going to be crucial for us to succeed with this next one, okay? So, and then this will be the last thing that we do today, okay? So, how about the equation negative 3x squared take away 6x plus 9 is equal to y? Okay, I'm going to give you 30 seconds to think, what would our first step be? Okay, so have a think. What would you do first? Okay, so hopefully you've got an idea of what you would do first. What we did first with these was to factor out whatever we had in front of the x squared. Okay? So in this case, we've got negative 3 in front of the x squared. So I would have to factor out negative 3 from everything. Okay? So if I did that, we would have x squared negative 3 times 2 gets me negative 6. Negative 3 times negative 3 gives me 9. There's our quadratic in there, ready for us to complete the square. But there's one other thing just to bear in mind. Quadratics which have a positive number in front of the x squared will give us a U shape. Excuse me. Sorry. Quadratics which have a positive number in front of the x squared will give us a U shape. Quadratics which have a negative number in front of the x squared will give us an N shape. Okay? So I'm expecting this quadratic to look like this and not like that. Okay? So, your challenge is to try and figure out where's its vertex, where are its roots, if it has any, and we'll throw in, can you find its y-intercept as well? And its y-intercept will be when x is equal to 0. Oh my god. When x is equal to 0. Sorry about that. Apparently talking can give you the hiccups. So, let's see how we do with this. What? I think 4 minutes again. 4 minutes was good. Okay. And again, feel free to ask questions, even if you think it's something small. Okay then, let's see how this final one pans out. And we're going to use a little bit of technology to help us along the way. So if you've got one of the swanky new calculators, this will maybe be of interest for you. So first of all, let's find our vertex. Okay, so I need to complete the square. So I've got negative 3x plus 1 squared. 1 squared is 1. I don't want 1, I want negative 3, so I need to take off 4 is equal to y. We can re-expand our bracket, so we've got negative 3 lots of x plus 1 squared. Take away 4 is equal to y. To find our vertex, we look at this bit and this bit. So when x plus 1 equals 0, we have x is equal to negative 1 and y is equal to negative 4. So there's our vertex. We now want to think about our roots. Okay. And you know, we could use the quadratic formula. We could do that fine. We could use our calculator, which we're going to see in a minute. We're just going to use the same method that we did before, just for consistency. So we're going to do add 4 to both sides. So we're going to have when y is equal to 0. So we're going to have when 3 lots of x plus 1 all squared is equal to 4. Positive number. So it looks good so far. We're going to have to divide by negative 3. Okay. Now, hang on a moment. I've made a mistake. Here we go. So, my mistake has come in over here. Yes, there we go. Celine's got it. There we are. That should be negative 12. Good spot. Positive 12 even. Positive 12. Good spot. Okay. Let's see what else that changes. So that will change this to be 12. That means that this would be 12. And when we change it over to the other side, it would become negative 12. Okay. Any other mistakes anyone can spot while we're at it? Don't think so. No, I think that looks good to me now. Yeah, I think that looks good to me now. Okay. So we look to divide by negative 3. So negative 12 divided by negative 3, that gives us positive 4. Okay, so we have a positive number. That means that we will have roots. Okay. We have to then square root both sides. So x plus 1 is equal to plus or minus square root of 4 is 2. So then x is equal to negative 1 plus or minus 2. So x with a plus, we will have negative 1 add 2 is 1. And x with the subtract, we'll have negative 1 take away 2, negative 3. So let's put all of that information together and see what our quadratic looks like. So here we go. We have a root at x is equal to 1. We have a root when x is equal to negative 3. We have a vertex at negative 1, 4. Okay, and notice again, the vertex is exactly halfway between our two roots. Plotting time. Boom. Oh wait, 4, 12. Looked at the wrong thing again. Why did I look at that? Oh, I looked at the coordinate. There we go. Let's move that where it needs to go, up there. Never mind. We all make mistakes. At some point. Okay? So, that's better. Now, if you have one of those, this is about to get 99% easier for you. Okay? If you don't have one of these particular brands of calculator, you might want to watch this, okay, just for the sake of having, watching how it works and things like that. Okay, your calculator can actually do all of this for you. Okay, it will actually do the majority of this for you. Okay, you just need to know how to program your calculator properly. So, if you press your menu button, you get confronted with all the different things that your calculator can do. We want to look for the mode for equations and functions, which in this option is option A. So I'm going to press this button to get option A. Do we have simultaneous equations? No, we just have one equation. This is what we call a polynomial. So I'm going to press 2. It's asking us what degree have we got. It just means, do we have like a quadratic, a cubic? We want to type in the highest power that we've got, and the highest power is a 2. So then, hopefully you can see that it's given us like some boxes for us to fill in the values of A, B, and C in our quadratic. So let's do that for this one. We had -3, -6, and 9. So you can see in my quadratic there, we've typed in those 3 numbers. We're going to hit equals. And what it's going to show us on the display, first of all, are our roots. So we've got a value, a root when x is equal to 1, which is what we had before. We have a root when x is equal to -3, which is what we had before. We have the maximum of this, okay, in which case this is talking about our vertex, when x is equal to -1 and when y is equal to 12. It has told us all of this information all in one go. Very, very helpful, especially for error checking. Okay? And then it goes back to the quadratic screen just in case you want to try another one. Okay? One thing to bear in mind is that where we said before, if the number that we get here is negative, we have no roots. This calculator knows how to deal with that. Okay? So you'll have to be careful to recognize when it's talking about roots that we don't need to think about. Okay? But for error checking, that is extremely helpful. Okay? And it will also do all of the solving quadratics for us in order to get the roots and things like that. It is very, very helpful. Okay? Now, we've been going for nearly 45 minutes now. I think that's long enough for today. Yeah, another reason to have a think about these. I'm not going to say that these are essential, but if you have the expense available for one, because they aren't cheap. These models of calculator are not cheap, I will say that. For a calculator to be like £22 to £25 is a sizable chunk. But if you have the expense available, these are extremely good calculators, especially if you're considering doing some kind of either statistics or AS level maths or A level maths or anything like that. These will become a must. But at GCSE level, they are a luxury. Okay. So yeah, I'm going to leave it there. Thank you for tuning in. No videos tomorrow. And I can't remember if I said that there was going to be one on Friday or not. It would be in the schedule if there is, and send that out at the beginning of the week. Okay. So yeah, I think next video that we do, we will perhaps look at something else, considering that we've looked at graphs for a very long time now. Okay, we've done like 10 videos on graphs? That's quite a lot. But yeah, we're going to finish it there. Go and enjoy the rest of your day. Okay, find something that you're going to enjoy. Have a go at that for some of the rest of the day. Okay, have a good one. I'll see you next time. Ta-ra.